Okay, in this video we're going to be going through accuracy and precision. So, accuracy and precision are quantities that tell how good a measurement is. So, in science we end up measuring a lot of stuff. These are very important because they can tell us if what we're measuring is valid and if the conclusions we're going to draw from it are going to be valid as well. So we're going to talk about accuracy first. So accuracy tells how close a measurement is to the actual value, or actual or true value. So for example, let's say there's a plant, plant, tree. If this plant is actually 3 meters tall, if that's the actual true value, accuracy is going to tell us basically how close we are to that. So if it's 3, is our measurement, 3.1? Is it 2.9? Are we under or over? So how close are we to what that thing actually is? And accuracy is going to be measured by something called percent error. I'm just going to abbreviate it with the percent sign. Percent error, which compares the true value and the measured value. So the percent error is basically a number that tells you exactly how accurate something is. So the formula for percent error is measured. So that's what you measure. That's what you're actually taking with the, your ruler or your scale or whatever. Then you're going to subtract that by the accepted. So what the thing actually is. If you had like a perfect measuring tool, what would that measure? And then you're going to divide that by the accepted. So again, what is the actual true value? And then you're going to multiply it by 100, and that's going to give you your percent error. So that's going to give you basically a number out that tells you how accurate your measurements are. How close are they to the actual value? And it's probably a good idea to, you could probably add not the scientific notation, the absolute value bars on the top, because the percent error is always going to be positive. It's really, you might have a negative number, you can just always think of it as positive. So it's probably a good idea to add the absolute value bars up here. So that is accuracy. So the second thing we're going to look at is precision. So precision tells how close measurements are to each other. So for example, if you had that same plant, tree, and you measured it one day and you said it was 4 meters, and then you measured it another day, let's say you measured it like the next day and you said it was 2 meters, right? Precision is going to tell you basically how close your measurements are to each other. So are your measurements consistent with each other? Are you getting measurements that are close to each other if you keep measuring the same thing? That's what precision is going to tell you. So precision is going to be measured by percent difference. And I'm going to abbreviate with the percent sign. Percent difference. And that's going to compare your average measurement. So if you were to take all of your measurements and average them together, and it's going to compare it to a particular measurement. So it's going to compare one measurement to the average of all your measurements. And percent difference, the way to actually calculate that, it's going to be your measured value, one measurement, minus the average of all your measurements that you've taken, and then you divide that by the average. And you multiply that 100%, and that's going to give you out basically a number that'll tell you, are you precise? Are your measurements close together? Are they consistent with each other? And the same thing, you should probably add in absolute value bars up here, because percent difference is always going to be positive. You might get a negative number out sometimes, but you can always think of percent difference as positive. So that's accuracy and precision, most of it. So accuracy, how close you are to the actual value, the true value of the thing you're measuring, and precision, basically how consistent, how close are your measurements to each other. So those are the two measures we're going to talk a little bit about more a little bit more about those right here. So in this, so you're going to get different numbers out for percent error and percent difference. And you basically need to, like, if you got, I don't know, if you got like 8% error, is that, you know what I mean, is that accurate or not? So for this class, we're just picking a threshold by which if you get percent error, percent difference under that, then you're going to have an accurate or precise measurement. So what I mean by that is, in this class, if you get a percent error, if you calculate the percent error, the accuracy of something, and it's below 10%, then you have an accurate measurement. And then the same thing for precision. So if you get a percent difference less than 10%, that would be a precise measurement, meaning that it's consistent with itself. So again, those are going to be kind of the values by which you'll be able to figure out if something's accurate or precise. And the last thing down here is kind of helpful with the bullseyes. So this is what we want all the time. In science, we want high accuracy, high precision. Right? If there's a dartboard and all the little things are all darts are measurements, we want all of our measurements to be close to each other. We want them to be precise, and we want them accurate. We want them close to the actual bullseye. And then again, all of these are basically examples of where that's one of the two is not happening. So like in this one, you know, it's precise, meaning they're grouped together, but it's not accurate, it's far away from the bullseye. In this one, you're pretty accurate, you're pretty close to the bullseye, but you're not consistent. All the X's are kind of all over the place. And then the last one, this is the worst of both worlds. This is low accuracy. So you're not close to the bullseye, you're not close to what you should be hitting, and you're not precise. You're kind of all over the place. So again, in science, this is what we want. We want high accuracy and high precision, and the percent error and the percent difference are going to be able to tell you if you are being accurate, if you are being precise. So let's go to the next part. So that's going to be a problem with this stuff. And right here. So again, this is a problem with accuracy and precision, so make sure you do it out first before you see out the solution. So take a minute or two. So make sure you do it out, right? The problem, you're doing it. Okay, so we'll go through it. So in this one, this problem, we have a pharmacist, and this pharmacist is measuring out doses of, not exactly sure the pronunciation, it's citrazine, I think. So that's a drug. She's measuring out dosages of this drug, and the correct dosage is 5 mg, 5 milligrams. So that's what's happening, measuring out dosage of a drug. Would like to get 5 milligrams each time. So the first part is asking if the pharmacist measures out 4.6 milligrams, is that accurate? So again, for accuracy, we're going to need percent error. So we're going to calculate percent error, and it's going to be the measured minus the accepted value over the accepted value times 100%. And we're going to plug in for that. So the measured value, right, it says 4.6 milligrams. The accepted value is 5 milligrams. That's the correct dosage. And then we're going to divide by 5. That's the accepted again, times 100. And with the absolute value bars, that's going to come out to 8% approximately. So we're going to get 8%. So is that accurate? So 8% is less than 10%. That's the threshold. So yes, this is an accurate measurement. So if you're shooting for 5, you hit 4.6, yes, that's still accurate by the threshold we're going to set for this class. The second one is percent, well, I'm getting ahead of myself. So the second one, the pharmacist measures out 4.7 milligrams. And it says the average measured dose is 5.25. So he's measuring a bunch of doses. On average, he's hitting 5.25. And it's asking, is this measurement precise? So it's not asking, is it accurate? It's not asking, is 4.7 an accurate measure? It is, because it's even closer than the 4.6 in Part A. It's asking, compared to what the average is, the average measurement, the 5.25, is that precise? Is that measurement fairly close to where all of the other measurements were? So to figure out that for sure, we need percent difference. And percent difference is the measured over, not over yet, the measured minus the average over the average times 100. So we're going to get, what's the measured? The measured is 4.7 milligrams. The average is 5.25 milligrams. And we're over the average again. It's 100. Absolute value. And just a note before you get the answer, because everything's in milligrams, right? It's 5 milligrams, 4.6, 4.7. We don't have to worry about putting units in here. If it's all the same, percent difference and error is just it'll work out fine. So again, as long as all the units are the same that you're plugging in, it doesn't matter. We don't need to include them in the equation. So calculating all of this, it comes out to 10.5%. And that is greater than 10%. So this 10.5% is greater than 10%. So no, this is not precise. So this measurement was technically accurate. It was fairly close, but it's not precise because it's not close to the average measurement that's being taken. So that's a problem kind of relating to this. So make sure you have the notes copied down. Make sure you have the solution copied down right here. And that's it for now.